13.8 billion years is how old the universe is, according to data from the Planck satellite and the European Space Agency. And the precise number sits at 13.787 billion years, with a margin of error around 20 million. You've probably heard that number before, maybe memorized it for a test, nodded when someone mentioned it, possibly repeated it at a dinner party to sound smart. But here's what decades of staring through telescopes and running the mathematics of existence have taught me. You have never, not once in your life, actually understood what that number means. And that's not an insult, because your brain physically cannot process it, since the hardware wasn't designed for this kind of calculation. When I force your mind to genuinely confront what billions of years actually contains, everything you think you know about your place in existence is going to collapse. And then, if you stay with me, it's going to rebuild into something far more extraordinary. There's a clock at the National Institute of Standards and Technology in Colorado, an optical lattice clock that won't need adjusting for roughly 20 million years. The engineers who built it will be dead within decades, and their great-great-grandchildren will turn to dust before it loses even a single second. That clock, that monument to human precision, measures the equivalent of a cosmic eye blink, because 20 million years is a rounding error on the scale we're about to explore, so close to zero that it might as well not exist. Let me show you why your intuitions betray you. If you sat down right now and started counting at one number per second with no breaks, no sleep, and no pauses, you'd reach 1 million in about 11 and a half days. That's manageable, something you could accomplish on a long vacation if you were sufficiently obsessed. But counting to 1 billion at that same pace would take 31 years, meaning you'd start as a young adult and finish middle-aged. The difference between a million and a billion isn't just mathematical, it's experiential, and those two numbers don't even belong in the same category. Yet we throw these words around as if they're interchangeable flavors of really big when they occupy entirely different universes of magnitude. Now multiply that confusion by 13.8, and that's the age of the cosmos. That's what you're claiming to understand when you casually reference the Big Bang. Carl Sagan, one of the finest minds to ever translate the cosmos for human comprehension, invented a thought experiment to address exactly this problem, and he called it the cosmic calendar. It remains the single most effective tool I know for forcing the human brain to confront deep time. The setup works like this. Compress all 13.8 billion years of cosmic history into a single calendar year, with January 1st at the stroke of midnight marking the Big Bang. The universe explodes into existence at that moment, with space, time, matter, and energy all erupting from a point of infinite density, a singularity that Einstein's general relativity predicts but cannot fully explain. Where does everything else fall on this calendar? Our Milky Way galaxy doesn't form until around March, which means that for the first 2 months of cosmic history, roughly 3 billion years, our galaxy didn't exist. The sun, Earth, and everything familiar to you don't appear until September, and that means for 8 months of this compressed year, there was no solar system and no place for you to stand. The atoms that now constitute your body were scattered across the galaxy in the wreckage of ancient stars that had lived and died before our corner of space even coalesced. Life appears on Earth around September 21st as simple single-celled organisms, bacteria, the ancestors of everything that would ever breathe or swim or think. And here's what should disturb you. For billions of years, which translates to months on this calendar, life was nothing but microbes, with no eyes, no brains, and no movement beyond the molecular, just cells dividing in ancient oceans. Complex multicellular life doesn't emerge until mid-December, and dinosaurs arrive on December 25th, Christmas Day, only to go extinct by December 30th. An asteroid impact 66 million years ago wiped out a dynasty that had ruled for 165 million years, which amounts to 5 days on the cosmic calendar, and then they were gone. And humans occupy the final 14 seconds before midnight on December 31st. Every pharaoh, every empire, every war, every symphony, every scientific revolution, and every person you have ever heard of exists in those 14 seconds out of an entire year. That's the proportion of human civilization to cosmic time, and we are not just newcomers. We are so new that we barely register. But here's what most people miss about the cosmic calendar, and I think Sagan himself would appreciate this observation. It actually distorts your perception in a subtle way by making the past feel long. December feels like it took a while to arrive because your brain fills in the months with a sense of duration. But 8 billion years, has no psychological analog. Your mind doesn't have a folder for that magnitude. And the cosmic calendar is a trick we play on ourselves to create the illusion of comprehension. It's tremendously useful, but you shouldn't mistake the map for the territory. Now let me take you somewhere that will genuinely restructure how you see reality. Because we've been looking backward, and the future extends forward with equal incomprehensibility, and it is far, far longer than the past. NASA and astronomers worldwide have mapped the life cycle of stars like our sun with extraordinary precision. 5 billion years from now, give or take a few hundred million, the sun will exhaust the hydrogen fuel in its core, and this isn't speculation because stellar physics and the mathematics of nuclear fusion guarantee it. When that fuel runs out, the core will contract under its own gravity and heat up dramatically, and the outer layers will respond by expanding outward. The sun will swell into what we call a red giant, growing so enormous that it will engulf the orbits of Mercury and Venus. Earth might technically survive, orbiting just outside the expanded solar surface, but survive is generous vocabulary. The oceans will have boiled away billions of years earlier, the atmosphere will be stripped, and the surface will become molten slag. Every fossil, every artifact, and every trace that anything ever lived here will be erased and sterilized, leaving our planet as a scorched cinder orbiting a dying star. And that's not the end, that's just our local drama. The sun will eventually shed its outer layers in a planetary nebula, a beautiful shell of glowing gas expanding into space. And what remains will be a white dwarf, a stellar corpse about the size of Earth but containing the mass of the Sunday. This degenerate matter becomes so dense that a teaspoon would weigh tons, and that white dwarf will sit there slowly cooling and radiating away its residual heat for billions upon billions of years. Eventually, on a scale that dwarfs everything we've discussed, it will become what physicists theoretically call a black dwarf, a cold, dark, dead remnant. But here's what should genuinely astonish you. No black dwarfs exist anywhere in the universe. Not a single one. The cosmos is nearly 14 billion years old, and that's still not enough time for a single white dwarf to cool completely, which means we are living in the early universe. You think we've arrived at the end of some long cosmic story, but we're at the beginning, and the stelliferous era, the age of stars, has barely started. Push further and ask what the universe looks like in 1 trillion years. Most of the stars visible tonight will be dead. Stellar formation will have slowed dramatically as galaxies exhaust their available gas and the night sky. If anyone or anything were around to observe it, would be profoundly darker, with fewer pinpricks of light and more void. The galaxies themselves, the great island universes that Edwin Hubble first proved existed beyond our own, will have drifted so far apart that they'll vanish beyond each other's observable horizons. This is where Einstein's relativity becomes viscerally disturbing, because space itself expands. Galaxies aren't flying apart through space, rather space itself is stretching and carrying galaxies with it. That expansion appears to be accelerating, driven by what we call dark energy, a phenomenon we've measured but don't understand. In the deep future, distant galaxies will recede faster than light can travel, and they won't disappear because they've moved, they'll disappear because the space between us has grown so large that their light will never reach us. A civilization arising in that distant era would look out at the cosmos and see nothing but their own galaxy floating in an infinite, empty void, with no evidence that other galaxies ever existed. The cosmic story written in tonight's sky would be invisible to them, erased not by destruction, but by distance and time. And here's the part that keeps me up at night. The cosmic microwave background radiation, the afterglow of the Big Bang, the oldest light in the universe, discovered by Arno Penzias and Robert Wilson in 1964, is fading. Expansion is stretching it, redshifting it toward longer and longer wavelengths, and in that far future, it will be undetectable. Future scientists will have no evidence of the Big Bang, and they'll look out at what appears to be a static, eternal, lonely cosmos, with no way to deduce that it began in fire and fury 13.8 billion years before their time. We happen to live in an epistemological window, a brief cosmic era, when the universe is young enough and compact enough that we can still read its history. The ancient light reaches us, the galaxies haven't fled beyond the horizon, and the evidence exists. But that window will close, and the universe will become a mystery, even to those living inside it. Consider the implications for the search for extraterrestrial intelligence. The Drake equation, Frank Drake's famous framework, for estimating how many communicating civilizations might exist in our galaxy, contains a variable called L, representing the length of time a technological civilization remains detectable. The question is, how long species like us last before they destroy themselves, lose interest in broadcasting, or evolve into something unrecognizable? We've been transmitting radio signals for about a century, which is 100 years against the billions of years of cosmic history, and that duration doesn't even register. What Enrico Fermi observed, in what we now call the Fermi paradox, is that even with conservative assumptions, the galaxy should be teeming with evidence of intelligence, yet we see nothing. One possibility is that civilizations rise and fall, like flowers blooming in a vast garden, never quite overlapping, with each one experiencing its moment of cosmic awareness before fading, like ships passing in the night, except the night lasts forever and the ocean is infinite. We might have missed them all by a few million years here or a few billion years there, and in cosmic terms, that's nothing. The timing problem isn't just about space, it's about time, and time is the harder problem. Pushed to the truly extreme timescales, to 10 to the power of 100 years, a number called a googol that would fill pages if written out, and you reach an era when even black holes will have evaporated. Stephen Hawking demonstrated that black holes aren't eternal, and through a quantum mechanical process now called Hawking radiation, they slowly leak energy and mass. For stellar black holes, this takes perhaps 10 to the power of 67 years to complete. And for the supermassive black holes at the centers of galaxies, monsters containing billions of solar masses, the evaporation time stretches to 10 to the power of 100 years. These are incomprehensible durations, but they are finite. Eventually, even these gravitational titans dissolve into faint wisps of radiation, and what remains is almost nothing. A thin, cold soup of particles and photons spreads so diffusely across such enormous volumes of space that nothing interesting can ever happen again. The second law of thermodynamics wins. Entropy maximizes, and the universe approaches equilibrium in what we call heat death, the final silence. But let me offer something most popular science presentations won't tell you, because they prefer the drama of finality. We don't actually know if heat death is the end. Physicists like Sean Carroll have pointed out that in infinite time, with quantum mechanics in play, fluctuations could potentially spawn new configurations of matter, possibly even new Big Bangs. The universe might not end. It might seed descendants, and we genuinely don't know. That uncertainty strikes me as more honest than confident predictions of eternal darkness. What does any of this mean for you, standing here today, on this small planet in this thin slice of cosmic history? Here's what happens when you truly internalize deep time. The questions themselves transform. People ask me whether there's meaning in a universe this vast and ancient and seemingly indifferent, and they feel small and insignificant. I understand that response because it's natural, but they're missing something profound. You are not separate from this story because you're woven into it. Every atom in your body was forged through stellar nucleosynthesis, the process where stars fuse hydrogen into helium, helium into carbon, and carbon into oxygen, working all the way up the periodic table, and then scattered across space when those stars exploded as supernovae. The calcium in your bones came from a star that died before our sun was born, and the iron in your blood originated in a stellar core collapsing. You are not living in the universe. You are the universe arranged in a particular pattern, temporarily animated and capable of wonder. That's not poetry, that's physics. Voyager 1, launched in 1977, has been traveling for nearly half a century and has barely scratched the edge of interstellar space, with its signals taking over 22 hours to reach us. It's the farthest human-made object from Earth, and it's essentially still in our cosmic backyard. Yet we built it, we sent it, and we extended our presence and our curiosity beyond this world, and that matters. Right now on the cosmic ledger, there's one confirmed entry under places where the universe figured out what it is. And that entry describes a thin layer of breathable gas around a small rock orbiting an average star in an unremarkable galaxy. That's the whole list. And you're standing on the only line item. The James Webb Space Telescope is currently peering back over 13 billion years, showing us galaxies that formed when the universe was less than 5% of its current age. We're reading the universe's autobiography written in light, and we're the first generation of our species with the technology to turn the earliest pages. Some people find the cosmic perspective terrifying, with the vastness and the timescales and the apparent inevitability of endings. I understand that. And terror and wonder are cousins living in the same part of the mind. But when you push through the terror and sit with the immensity of it all, what emerges is something like gratitude. You got to exist during this window. You got to see the stars before they die. You got to ask the questions, and you got to know. The universe spent 13.8 billion years doing chemistry, with hydrogen becoming helium, helium becoming carbon, and carbon becoming complexity, until somewhere and somehow, on at least one world, that complexity became curious, became aware, and started measuring the thing that made it. That's what you are. Not an observer of the cosmos, but a participant, a collaborator in the project of existence, becoming aware of itself. The universe doesn't owe you meaning, but it gave you something better in the capacity to create it. And it gave you this window, this brief and irreplaceable window, to look back at its birth and forward to its death and understand what you're part of. This window will not last forever, and future minds will inherit a darker, emptier, more mysterious cosmos. But you live in the era when the story is still visible, when the light still reaches us, when the questions can still be answered. That's not a burden, that's a gift beyond calculation. Don't waste it.